In today's video, we're going to talk about hormonal control of metabolic pathways. The main pathways we've covered so far include glycolysis, gluconeogenesis, and glycogen synthesis. As we've discussed a little bit in class, the main hormones that control metabolism are going to be insulin and glucagon, and also will include epinephrine because many of its effects are very similar to glucagon. Just to remind you, the main effects of insulin are to lower blood glucose concentration. Alternatively, the opposing hormone, glucagon, its main function is to increase blood glucose concentration. Now, epinephrine does essentially the same thing, but it does it much, much more rapidly than glucagon. So a real handy way to summarize all of the effects on those main pathways I mentioned earlier is to come up with sort of a simple figure that I think will help you guys sort of integrate the information that we've been talking about. So in order to do this figure, what I'd like to do is just envision now, let's say we have a blood vessel, and glucose is now in the blood. And over here, let's now draw a cell. Okay, so there's sort of our outline of our cell. Now, insulin, I'm going to draw like this. Okay, it's a small peptide. And insulin, when it binds, it's going to bind to the insulin receptor, which is sitting right here on the cell membrane. Now, when insulin binds, what that will do is the following. It's going to cause small vesicles. That's not a very good color. Let's try this one. It's going to cause small vesicles that contain GLUTs. GLUT, these are proteins that basically form a channel so that glucose can now enter into the cell. So these channels are called glucose transport proteins, or GLUTs, G-L-U-T. And when insulin binds, it's going to allow these GLUTs to sort of fuse with the cell membrane, allowing the glucose that's in the blood to now flood into the cell. So now we have glucose in the cell. And as we've talked about, glucose, once it's in the cell, tends to be trapped in the cell. Cells are very greedy when it comes to the fuel, glucose. So oftentimes, glucose is going to go through the process of glycolysis to give you pyruvate. And the very first step, as we talked about, is the phosphorylation of glucose. That's going to trap it in the cell. So this pathway, glucose to pyruvate, let's just indicate that that's called glycolysis. And I'll put a sort of cloud box around that. There's 10 steps that we've talked about prior to this video. Definitely need to know those. Let's continue around with our figure, though, and then we're going to come back and insert what the effects of insulin and glucagon are. So glucose can be converted to pyruvate. Alternatively, pyruvate can be reconverted back to glucose through the process called gluconeogenesis. And that's an 11-step pathway that we've talked about previously. Lastly, let's just put in glycogen. Okay, the storage form of glucose, the insoluble storage form. And glucose can be converted into glycogen through the process of glycogen synthesis. Okay, 3 steps to that pathway. Or alternatively, glycogen can be degraded back to glucose. That's the process called glycogenolysis. Or the breakdown of glycogen into glucose. So let's take a look at now what the effects of insulin are, and then we'll come back and talk about glucagon. So if insulin's main function is to lower blood glucose concentration, it's going to cause any pathway that will convert glucose into something else. It'll sort of activate that pathway, essentially shifting the equilibrium by moving glucose to something else, and that's going to help draw the glucose out of the blood, essentially converting the cell into a glucose sponge. So again, any pathway where glucose is converted to something else, insulin will activate. So let's put that here. Insulin is going to activate this particular pathway, glycolysis. What's another pathway that's going to be activated? Well, glucose can be converted to something else, the insoluble form here in glycogen synthesis. So insulin will activate that pathway. And notice I'm using this sort of up arrow to indicate that that pathway is activated. Now conversely, pathways that make glucose, those will be inhibited by insulin. So over here, gluconeogenesis is going to be inhibited. So I'll put a little X next to that I, next to gluconeogenesis. Also, you'll see this pathway, glycogen going to glucose. That's a pathway that makes glucose. That would be inhibited by insulin. Okay? And the reason those two are inhibited is because those pathways make glucose, which essentially would shift the equilibrium to push glucose out into the blood. That's not the function of insulin. The insulin's function is to lower blood glucose concentration. So once you have those basics down, now we can talk about glucagon and epinephrine. They're going to have the exact opposite effects of insulin. So anywhere where we have an insulin as an activating pathway, glucagon, which we'll indicate with a G, let's use a different color here. Okay, that's going to have the opposite effect of insulin. So glucagon is going to inhibit glycolysis. Let's go around and let's put those opposing pathways here. So if insulin activated gluconeogenesis, glucagon is going to activate it. Likewise, glycogen synthesis, well, insulin activated that one. Glucagon is going to inactivate it. And then lastly, this pathway, glucagon, because insulin inactivated it, it will actually activate glycogenolysis. Lastly, let's put in epinephrine. Well, epinephrine has the same effect as glucagon, so we'll just list that as an E. So that's going to be up. E is going to be there. E is here. E is inhibiting that. Okay, so again, glucagon and epinephrine, they have essentially the same effects, but epinephrine does it much faster. I really like this figure as a way to summarize the major effects of hormonal control. I like to call this the G figure. And the reason I call it that is if you look at the figure, there's all these names that start with the letter G. It can get quite confusing to sort of remember all those. I think this might be a helpful way to do that.